let's talk a little bit more about the periodic table. So you have on the periodic table, you have your main group elements. Those are your group A elements. And then you have your transition elements here. Okay. The transition elements properties tend to be less predictable based on the element's position. All right, next slide. Okay, other things to know about the periodic table. You want to know that group 1A, these are the alkali metals, okay? Group 2A, these are the alkaline earth metals, okay? Group 7A, these are the halogens, and group 8A are the noble gases. You definitely want to memorize those. All right, looking for patterns. So just keep in mind that the patterns are that things that react similarly are kept in vertical lines. So in the alkali earth metals, these guys will all act very similarly under the same conditions. Alkali metals contain lithium, sodium, potassium, rubidium, and cesium. Then we have the alkaline earth metals, and that's beryllium, magnesium, calcium, strontium, and barium. The halogens include, and this is to the right of the periodic table, 7A. This is fluorine, chlorine, bromine, iodine, and astatine. And then the noble gases include helium, neon, argon, krypton, and xenon. So atoms will lose or gain electrons to form ions. In chemical reactions, atoms will often lose or gain electrons to form particles called ions. Ions means that it has a charge by it. Positive ions are called cations. Negative ions are called anions. The charge of an ion is shown in the upper right corner of the symbol. Okay, so like here, for example, you have O2 minus. It can also be written as O minus 2, but this here would be an ion. Okay. Ion charges are usually written with the magnitude followed by the sign, but you will see it both ways. All right. Now, the elements, or the atoms, they are going to lose or gain electrons to be more like the noble gases. So the number associated with the A, so if you remember the alkali metals, that was group 1A, the alkaline earth metals, that was group 2A, okay, and so on. They correspond 1 through 8. Okay, and this gives the number of valence electrons for each of the elements in that column. So the group 1A elements will all have 1 valence electrons. The group 2A elements will all have 2 valence electrons, etc. Down to group 8A, which will have 8 valence electrons. All right, the key to predicting the charge acquired by an element is its position on the periodic table with respect to the noble gases. So main group elements tend to form ions that have the same number of valence electrons nearest the noble gas closest to it. So if you keep in mind here, these are the noble gases. They have 8 valence electrons. 8 is like perfect. That means that there is they aren't really going to react. So everybody wants to lose or gain electrons to be just like them. All right, so if we were to take a look at the periodic table, let me see here if it's on the next slide. No. Okay, I'm going to pull up a periodic table for you to look at, and then we'll talk about the charges of the valence, or the charges that these atoms would have on them and why. Okay, so here is a periodic table that I have in your modules tab, and we're just going to look at this periodic table and talk about how you can tell what ion the elements will become in general. Okay, so if I were to look here at, let me go with my little pen. If I were to look here at lithium, hold on a second. Let me get a little pen going. All right. There we go. Lithium is right here. All right. You'll see that lithium has 3 electrons. Okay. Everybody on the periodic table wants to be like the noble gases over here with respect to electrons. Okay. So lithium, the nearest noble gas with respect to electrons to lithium is helium. So you'd go, all right, well, how many electrons would lithium need to lose to be just like helium? Okay, so since it has 3 and helium has 2, it would need to lose 1 electron. Okay, so lithium would have a Li 1 plus. Okay, it would have a +1 charge because it would lose 1 electron. All right, let's look at sodium. Sodium has 11 electrons. Okay, that circle didn't work out real well, but I think you guys can tell I'm talking about sodium here. What noble gas is closest with respect to electrons to sodium? Well, I look over here and I see neon. Neon has 10 electrons. Okay. So sodium would also need to lose 1 electron to be just like the noble gas that's nearest it. Okay, so sodium would be Na1 plus. All right, potassium, what noble gas is closest to it with respect to electrons? Argon. Okay, so argon has 18 electrons, potassium has 19. It would need to lose 1, so it would become K. 1 plus. Okay, so this here is your +1 row in general. I'm going to show you a periodic table in a minute that's going to have some charges and this one actually does, but they're really, really tiny. Okay, so this is your +1 row just in general. Now let's look at this row. This is actually your +2 row. Okay, and you guys can write that on here. 1 plus row, 2 plus row. Let's look at beryllium. Magnesium. Let's take a look at magnesium. Magnesium has 12 electrons. Okay, what noble gas is nearest it? Neon. Okay, so how many electrons would magnesium need to lose to be just like neon? It would need to lose 2. So its ion would be Mg2 plus. Okay, calcium, same thing, Ca2 plus. All right, so then we're going to we'll learn a little bit more. We have a chart that has these guys on it. Aluminum is 3 plus because aluminum would need to lose 3 to be just like neon. Boron is a semi-metal. Okay, so it's it can be a little bit different. But I'm going to show you a periodic table in a minute that you guys can just kind of memorize things. This row we're not going to really talk about. Okay, but then we have our nonmetals here. Okay, so if we look at, say, nitrogen, the nonmetals, what they do is they gain electrons to be like the nearest noble gas. Okay, the metals over here, they lose them, so they become positive charges, because if you lose a negative charge, an electron, you become positive. The nonmetals gain electrons, so they become negative. So nitrogen here has 7 electrons. The noble gas that's nearest it with respect to electrons is neon. Okay, neon has 10. So nitrogen would need to gain 3 electrons to be just like neon. So it would be N 3 minus. That's supposed to be a 3. This pen's difficult to write with. All right. Phosphorus here has 15. It would need to gain 3 to be just like argon. Okay, so P3 minus. You can think of this as your 3 minus row. There are definitely going to be some ones that are a little bit different than that, but it works for, the nitrogen and the phosphorus. This here, we have really just oxygen and sulfur. This is your 2 minus row because they would need to gain 2 to be just like the noble gas nearest it. And then these guys here, fluorine, your halogens, this is your -1 row because they're just one away. They would just need to gain 1 electron to be like the noble gas nearest it. So I'm going to show you the periodic table that's in the slideshow next, because you'll see that some elements are able to be more than 1 ion, and those unfortunately you have to remember. So that's many of the transition elements here. They're just not as predictable. Here's a periodic table with just some common ionic ions with their predicted charges. All right, isotopes. Okay, this is when your number of neutrons varies. All atoms of a given element have the same number of protons. Okay, so helium, for instance, will always have 2 protons. They do not necessarily have the same number of neutrons. Okay, atoms with the same number of protons but a different number of neutrons are called isotopes. All elements have their own unique percent natural abundance of isotopes. So we're going to talk about neon here. Neon actually occurs in a few different isotopes. Naturally occurring neon contains 3 different isotopes. There's neon 20, okay, which means that you have 10 protons and 10 neutrons. Neon 21 would have 10 protons. Remember, neon's atomic number is 10, so it's always going to have 10 protons. Okay, 10 protons, but 11 neutrons. I'm going to show you how we got to that number. And then neon 22 would have 10 protons and 12 neutrons. Okay, and then here are the relative abundances. So neon 20 is the most common. So you're like 90% of the neons that you would find on Earth would have the 10 neutrons, and then so on and so forth down to the neon 21 has the least amount. All right, so it's important to be able to show the number of protons and neutrons using atomic notation, or sometimes it's called isotopic notation, isotope notation. So you might see it different ways if you look this up. Isotopes are symbolized in the following way. So you have your elemental symbol, okay, so where they're using X, this could be like calcium, whatever. And then you're going to have your mass number on the top left. And remember, on the periodic table, your mass number is on the bottom. So this is opposite. So your mass is on the top left and your atomic number is on the bottom left. Your mass number is your sum of the protons and neutrons, and your atomic number is the number of protons in the nucleus. So these are the isotopic symbols for the different isotopes of neon. You can tell how many neutrons they have because of the difference in the numbers. So neon always has 10 protons, but to be able to tell how many neutrons, you're going to take that mass number minus the atomic number. So 20 minus 10 is 10 neutrons. This one here would be 21 minus 10, which equals 11 neutrons. And this one is 22 minus 10. So it would have 12 neutrons. But keep in mind the protons are always going to stay 10. That's what makes it neon. So to sum that up, the mass number is the number of protons and neutrons, and the number of neutrons in an isotope is the difference between the mass and the atomic number. For this video, you might also see another type of notation where they just show the elemental symbol like neon and then with the mass listed beside it, because we know that you know the atomic number of neon, but it's the mass that really might change because it's the neutrons that change in the isotopes. So you might see it written as Ne20 or Ne21, Ne21, Ne22, just like carbon. You might see C12 or C11, okay? All right, so we'll move on to the next video after this one. All right, thanks a lot, guys.